This video is part of the lecture for multivariable calculus, and I'm gonna solve some examples that show how to solve the double integral using the graph of the given function. Okay, so let me start. Example 1, evaluate the double integral of 10 dA over the region R, where R is 0.3 times 0.5. Okay, as I always recommend, graph whatever region that you have. So the function f of xy is actually what? The function is given as z equals to 10. This is the integrand that we have in here, z equals to 10. So I'm gonna graph it. How do I do that? I have x, y, and then z, and then as you see, z equals to 10 is just basically a plane that I have in here. And then this is z equals to 10. And then look at the region R. The region R is x from 0 to 3. So 1, 2, 3. And then y is from 0 to 5. 2, 3, 4, 5. Okay, so I have a region R in here, 0 to 3, 0 to 5. Let me show it to you. Z equals to 10, as you see. This is, the scale is 5, and then this is 10. It's a plane. Okay. Now, double integral has a meaning. Double integral is the volume of the solid that is bounded above by the given function, by the integrand, and then on the bottom it depends on the region R, on the bottom by the region R. Okay, so I would like to calculate the volume of this solid, which is a box in here, right? So I have like a box in here that I would like to calculate its volume. So the double integral of 10 dA over R is basically the volume of the box, of this box in here, which is what? It is 3, the sides would be 3, and then 5, and then the height is 10. Right? 150 is the answer for this double integral. Okay, and I didn't calculate the double integral. I used just basically the volume. Let me go to example 2. I would like to evaluate the double integral of a square root of 1 minus x squared dA over the region R, where the region R is this. Negative 1, 1, cross 0 and 4. You see, this is for x-axis, this is actually for y. Okay, let me try to graph this one as well. I'm gonna say that the function f of x and y, it's given as what? It's given as 1 minus x squared. This is my z. Okay, so if I want to graph it, I'm not that much comfortable with the square root. That's why I square both sides. I get this. Then I'm gonna bring, so let me write a square both sides. And then I'm gonna bring x squared on the other side, so I get this. Oh, x squared plus z squared actually is equal to 1. What is that? It's a circle of radius 1, center, origin, right? And it's on the xz plane. As you see, y is free. Okay, since y is free and we have a circle on the xz plane together, we have a cylinder. So the shape is actually a cylinder that lies on y axis, right? Because y is free, so we have like this shape, you see, x-axis, y-axis, and then z-axis. And I have a circle, but pay attention that on this circle it is not actually a full circle because z is square root, which means that z is always positive. Okay, pay attention to this fact as well. Let me have some space in here, and I'm gonna say that but z is equal to 1 minus x squared, so z is positive. Okay, so when z is positive, it means that we have the top semicircle, top half of the circle. So what do we have in here? We have the top half of the circle of radius 1 on the x, y, on the xz plane. This is the radius 1, just top half of it because z is positive. And then y is free, so it moves on the y-axis, something like this, you see? Something like that, right? And then region R, x is from -1 to 1, perfect. It's from -1, which is this point in here, to 1, and y is from 0 to 4. So it's 0, I can go up to 4. Okay, let me show you to the graph as well. Okay, so where is the graph actually? Let me see. There you go. You see, this is x-axis, this is y-axis, and that's the top half of this cylinder. Z equals to square root of 1 minus x squared. Okay, but what do we want? We just want y from 0 to 4. We just want just this part in here. Okay, so how do I calculate that? Well, I say that the double integral of 1 minus x squared dA, okay, is basically what? It's just the top half of the cylinder, the cylinder that we just described in here. And it's what? How can I find the top half of it? First of all, the area of the base is not a full circle. It would be half of the area of a circle, pi r squared. Okay, so this is actually the radius of the circle, which is 1. And then, so I get pi 1 squared. This thing in here would be the area of the full circle. I just want half of it. And then for this kind of lying cylinder, we just want the height times the height. And what is the height? The height is 0 to 4, so this is 4, right? So it would be 1/2 pi 1 squared times 4. So this is 2 pi. That's the answer for this integral.